Tanya, and thanks for having me at this amazing conference. I hope next year we'll be in presence in the future. Really hope so. So, good afternoon to everyone, and welcome to my presentation. My name is Enrico Zimuel, and I'm a principal software engineer at Elastic. And today I would like to introduce you Elasticsearch and how to program Elasticsearch using PHP, of course. So this is the agenda. We are going to have a very brief introduction to Elasticsearch. I will talk deeply about PHP, of course, how to use Elasticsearch in PHP, how to connect to Elasticsearch, how to index bulk on search documents in Elasticsearch, how to leverage advanced feature of Elasticsearch like the fuzzy search, the aggregation, and also I will talk to you about a recent feature that we added in the engine of Elasticsearch. That is a schema on read. It's very interesting. Finally, we have some introduction to the async communication that you can leverage using the Elasticsearch PHP client. And last but not least, we will talk about the future of the PHP client. So what is Elasticsearch? I know more of you are familiar with this engine, but just to give a brief introduction. So basically it's a distributed free and open search and analytics engine for all types of data. So Elasticsearch scaled by design, and it's built to manage any size of data. In fact, there are many installations of Elasticsearch worldwide with terabyte or petabyte of data. It's one of the killing features of Elasticsearch is actually that is very, very fast. We say that is near real-time search. So basically, when you send a query, the response will be in some milliseconds. It offers a wide range of features like filtering, aggregating data, analyzing data, and order any type of information. And basically, it's a document-oriented database using JSON. So you can basically store objects or documents in Elasticsearch, any kind of object and documents. A collection of documents in Elasticsearch is called an index, that you can think like a table in a relational database in a SQL. All the features of Elasticsearch are managed using a REST API. So we don't have a client or a shell tool to connect to Elasticsearch. You have just a REST API. So that means you can use every client, every HTTP client. For instance, if you are on a command line on Linux, you are using cur, you can run this command from the command line that basically say, okay, look, I want to send a GET request to this address, localhost with port 9200, that is the default port of Elasticsearch. And Elasticsearch will send you back a response that is a JSON document, something like this. So as you can see, we have kind of information about the naming of the instance of Elasticsearch in localhost. For instance, the version number, in this case is 7.12.1, and so on. So very, very simple. Okay, how you can actually install and run Elasticsearch on your machine? The easy way is to use the Docker elastic.co images. So we provide a special website that you can check it out in order to select the Docker image that you want to use. You can run the usual command of Docker pulling the specific version. For instance, this is the 7.14.1. That is the latest Elasticsearch version available. And when you have it, you can just, for instance, run a single node on your machine on the default localhost 9200 port. And this is the command. So basically run the Docker image that you pulled before, specifying the port. And you have to specify the type that is single node, because as I mentioned, Elasticsearch is a distributed database. In this case, you can just simply run one instance on your machine. But you can also use Elastic Cloud, that is the software as a service provided by Elastic solution, and you can leverage all the advanced feature like, for instance, this is a screenshot of the Kibana. that is already in place in the Elastic Cloud. So when you have when you subscribe and you run an instance on Elastic Cloud, you will get back all the feature without managing, installing and managing any software. We offer also a free 40 days trials with no credit card required, so I strongly suggest to check it out. Okay, let's jump to the main focus of this presentation, that is, of course, how to use Elasticsearch in PHP. So we offer, and actually I'm the maintainer of this project, an open source library for PHP in Elasticsearch. This is the name of the project in GitHub, is elastic/elastic-php. And this released every time we release the Elastic Stack. So, for instance, more or less every 2 months we have a minor release of Elasticsearch. Now we have 7.14. In the next 2 months we will have 7.15, and we will release the same day the Elasticsearch-php client. Why? Because we need to update all the API, all the new feature that Elasticsearch provided in PHP. The cool feature of this client is that it uses a connection pool for cluster configuration. So basically it means that if you are running an instance of Elasticsearch on different nodes, you can specify the IP address of these nodes into Elasticsearch-php, and the client itself will manage a connection pool for you. So you don't have to manage manually using round-robin algorithm, whatever. It's already in place in the client. As I said, we release on each stack version all the endpoints, all the API. And just to give you an idea, right now there are almost 400 APIs available in Elasticsearch, so a lot of API. And we expose these endpoints using function in PHP. So we have a client class with a lot of methods, and this function are basically the endpoints that you can call to perform the Elasticsearch operation. So very, very easy. Each function returns the body of the HTTP response from Elasticsearch or a Boolean value, depending on the operation. For instance, if you want to check if some index, and index is basically a document that is present in the database, exists or not, the answer will be true or false. Basically, you will not have the body of the HTTP response, because from a technical level, this is a head HTTP method, HTTP call. So there is no body, basically. If it's successful, we return true. If it's not, we return false. But for the majority of the API, I would say you will have back the body of the HTTP response. And actually, we deserialize the body, because the body, as I mentioned, is in JSON. So the HTTP response is in JSON. We deserialize it. By default, we are using an associative array, but we offer a serializer interface. That means if you want, you can serialize into a class, into an object, into whatever you want. So by default, we provide associative array, but you can implement your custom serializer. In case of HTTP errors, for instance, 400, 500, and so on, we throw an exception, and we provide an Elasticsearch exception interface, basically. For instance, you can have specific exception when you try to, I don't know, get an index that does not exist. You will have a missing 404 exception, for instance. All the endpoints are generated using the REST API specification of Elasticsearch. So I will share the slide with the organizer of the conference, and each time you will see a link like this with the blue, with the underscore. This is basically an hyperlink. You can click it, and in this case, you will open the REST API specification of Elasticsearch. So basically, in the Elasticsearch project itself, that is also an open project on GitHub, you have the REST API specification, basically a collection of all the request and the response and the parameters that you need to send to the HTTP REST API in order to perform, the action to Elasticsearch. So basically, what we are doing is reading this API specification and generating from this API specification the code, all the function that I mentioned earlier. So everything is generated, basically. We test the client, of course, using unit tests, but also using integration tests. And actually, we have more than 2 1,400 tests in place, so a lot of tests, because basically we are reusing the same test that the Elasticsearch project itself, that is written in Java, is using in order to test the Elasticsearch. So we are using the same test. So we care a lot about testing, of course. It's a quite popular project, I would say. I just checked today, and we have more than 54 millions of download. And an average of this, you can see here the statistics. This is basically the screenshot of the packages.org website that manage, all the libraries of the PHP projects. These are they installed with the average monthly, and you can see that right now we are almost 50K downloads per day, so it's quite a lot. As I mentioned, all the endpoints are exposed using functions, and just to give you an idea, if in this table I map on the first column the Elasticsearch API, and in the second column the PHP function. As you can see, if you want to perform, for instance, an index API, you need to send a put with a specific URL and of course a specific body. This is mapped in the PHP client using the index function. So we use the same name of the API as the name of the function. So index, bulk, update, and so on. As you can see, we have also some namespace, because, for instance, there are some API that are collected together. All the API that manage a cluster are collected under the namespace cluster. So basically, we provide a way to have a function cluster in the client that offer all the specific sub-function of the cluster. So this is the way that basically you need to call the cluster stats. So basically you call first a cluster function that of course is empty, it's just a namespace holder, and you perform the stats. As I mentioned, all the API are a function, and they have a $params array. So each function has this associative array that contains all the parameters to perform the action. And this is just a screenshot of the source code. So if you open the source code of the library, you will see that all the endpoints are documented using this verbose PHP doc that gives you all the possible information. So all the possible key inside the associative array. So for instance, the ID, the index, the type. We also have some type that are not strict PHP type, like enum. Actually, enum will be introduced in PHP 8.1, but right now we don't have the enum type in PHP, but this is the enum property of Elasticsearch. So you have just to read basically the description to understand what it means. And of course, we also provide in the etc, as you can see here, the hyperlink to the documentation. So if you click here, you will have the specific page of Elasticsearch documentation, so you can check it out and understand how to basically create the requests to a specific index API in this case. Okay, how you can install Elasticsearch-php? Of course, using Composer. This is the command. The name is Elasticsearch/Elasticsearch. Or you can add in your Composer JSON they require. Right now we have the latest version, that is 7.14. How you can connect to Elasticsearch. So let's start to see how to use basically this library. I will give an example using the localhost 9200 default port, and for instance, we want to perform the info API. This is basically an API that gives some information about the instance of Elasticsearch that is running. So the first thing that you have to do is to create the client class. And in order to do this, we have a client builder that is a factory. We use the factory design pattern to create the instance. In this case, we need to specify only the host. And as you can see here, the function specifies the hosts as plural. So you need to use square bracket here to insert the list of all the nodes that you have. And in this case, it's just one. So it's just one string. You perform a build, and basically the $client will be the client class where you can actually execute all the endpoints. As I mentioned, we are interested in calling the info API. The info API does not provide you any parameters, so we can just call info without any parameter. And for instance, I just var dump the result just to understand how the library perform the request. So this is basically the var dump. As you can see, is the deserialization of the JSON that I showed earlier in using associative array. And inside, for instance, the this array, you can see the number that is the version of Elasticsearch that is running. This case was when I run this example and a copy and paste was 7.10. That's it, very simple. So basically, each time you perform a function, you call an endpoint of Elasticsearch, you will have back this $results. This is an associative array that you can introspect to read the results from Elasticsearch. Okay, imagine now that we want to connect to a cluster of nodes, not just one instance, but a set of nodes, so a cluster. How we can do that? Very simple. We can just specify the list of the IP address with the specific port in the set host. For instance, here we are specifying a cluster of 3 nodes, and that's it. So we don't have to do nothing more. For instance, if you want to call the cluster health API that gives you information about the health, the status of your cluster, we can just perform this endpoint cluster health. We var dump the results, and as you can see here, we have another associative array with other information. Because we are interested in cluster, now we have all information about the cluster. For instance, the number of nodes. For instance, you can see here that is 3. Number 3, because we have 3 nodes in place, and so on. I mentioned that Elasticsearch-php is able to manage a connection pool. So connection pool, basically, it manages the connection between multiple nodes. So imagine that we have 3 nodes, Elasticsearch 1, 2, and 3, with the previous IP address. And we have our PHP client. So each time we perform an endpoint, each time we call an endpoint using the PHP client, the PHP client will send the first request to the first, to the first node in the list. In this case, Elasticsearch 1. The second time to the second, the third time to the third nodes, and so on. So basically, we restart again 1, 2, 3, 1, 2, 3, 1, 2, 3. So each time it performs to a different, node. So basically, we spread the traffic, and we use all the cluster. So that's the idea. By default, we offer a round-robin algorithm for the connection pool, but you can implement your algorithm implementing an interface, basically. So imagine now that for any reason the node 1 is going down, so it's not available anymore. Automatically, the PHP client is able to understand, okay, the Elasticsearch the node 1 is not available anymore, so I can reduce the connection pool. So now we have only the node number 2 and the node number 3. So automatically, the PHP client is able to manage this scenario and reduce the connection pool to using only the 2 available nodes. There are also logic of resurrection. So in the PHP client, there is also something like if you're running a PHP script in memory, imagine the situation. If you are using, I don't know, some asynchronous implementation using Zimuel or React PHP. So you have some PHP script in memory that runs forever. Of course, in this case, the PHP client is able also to say, okay, after, I don't know, 5 minutes, I will try to ping again Elasticsearch 1. If I will receive a positive response, I will connect again. So I will resurrect the node 1. I will insert 1 in the pool. So the next time, basically, we are going to reuse again pull the node 1. But generally speaking, if you have a web application that does not stay in memory, this will never happen. Because as you know, a PHP script, the lifetime of a PHP script is a few milliseconds. So there are not so many, interaction typically in Elasticsearch. But still, we support the both scenarios. As I mentioned, we have also specific interface to customize the logic of the connection pool or the selector for selecting, specific nodes. We provide by default the round robin, the sticky round robin, that is basically an algorithm that say use the current connection unless it's dead, otherwise use round robin. And we also offer a random select node. But again, if you want to customize the implementation, you can just implement your custom selector interface and configure the client to use that. And in order to do this, you have a set selector function in the client builder. So you can just specify the name of the class in the set selector. That's it. Okay, imagine now that you choose the other way. So you tried the Elastic Cloud. So you want to connect your PHP application to the Elastic Cloud. You have to basically you have to use the Cloud ID and the API key. These are two pieces of information that are provided in the Elastic Cloud backend in the administrative console. So you can copy and paste it and use the set Elastic Cloud ID and the set API key in order to put this information. So very, very simple. So in this case, you don't have basically to manage the Elasticsearch instance by yourself. You are just consuming in a typical software as a services scenario. Okay, let's focus a bit more inside the PHP and how basically PHP manages. And we know that we have in PHP two functions to manage JSON document that are JSON encode and JSON decode. So encode to have as results a JSON document in a string, decode the opposite, the vice versa operation. So you start from a JSON document, so a string, and you will get back an associative array or an object. By default, as I said, the Elasticsearch-php uses associative array when they serialize the response. Starting from PHP 7.3, we can use a parameter in the JSON encode and decode that is JSON throw on error. This is a constant that throw a JSON exception in case of error. And actually, we are leveraging this function in Elasticsearch-php. So when basically we have something that is not JSON compliant, we catch this JSON exception. There are other information important to know about JSON and Elasticsearch, because for some API of Elasticsearch, it uses some empty JSON object. An empty JSON object, how we can actually write in PHP? Because we are talking about associative array. How I can write an empty object using an associative array in PHP? So imagine that we need to basically create this JSON using associative array of PHP. So this is a query. This is part of the document that perform a query for searching document in Elasticsearch. As you can see here in the highlight fields content, we have an empty object. How we can map this into an associative array in PHP? We need to create an empty object. So here in the content, we need to create a new standard class. Standard class, as you know, is the standard class of PHP. So we create basically an empty object here. So this is important to remember. So each time you have an empty object in JSON, you need to create, for instance, a new standard class. There are, of course, other ways to create an empty object. You can even cast object as, for instance, an empty array or other, other way to do that. But this is the most simple one. Just create an instance of an empty standard class object. Okay, let's focus now with some example. Imagine that you want to index a document. So you want to store a document, a JSON document into Elasticsearch. How to do that? We have an index endpoints. So basically here we are just creating the client. We are specifying the parameters that we want to insert. And actually you need to specify two parameters. One is the index name. In this case is my_index, and the other is the ID. So the specific ID of the document. And the document itself is specified in the body. So the body field represents the documents. And inside we have this simple document. This is just an associative array with one element. And that's it. I mean, you pass the $params in the index endpoint and we will get back a results. A results is, again, an associative array, and you have this result field where you have the specification if the request was successful or not. In this case, created means, of course, successful. You can also send multiple documents using the bulk API. So we have a specific API in Elasticsearch to index, create, delete, and update multiple documents in a single request. So basically you are doing one HTTP call, one request, and inside the request you are managing multiple documents. So you are sending multiple documents. This is typical because if you want to imagine that you want to insert 100 documents in Elasticsearch, you can perform a loop calling 100 times index, but this will be translated into 100 HTTP call to Elasticsearch. Or you can use the bulk index, have just one HTTP call, and inside the body, basically, you will have all the documents. In order to perform this, technically, we use ND-JSON. That is a special JSON format that gives you the possibility to specify multiple JSON document. Basically, it's a JSON with you have a return, carriage return, and another document. So multiple documents separated by return. How you can do that in PHP? You basically have to create an array of body. So inside body, so this is the famous $params that we showed earlier. Here we are just creating with a loop, we are just adding 100 documents. So you need to create 100 elements actually in the body. Actually 200, because you have the first element is the specification of the index, and the second element is the body. So you have two for each, because basically for each HTTP call, you have two information, the index and the body and the document. So you can just create this array, and at the end you can just perform one HTTP call that is bulk, and this will send all the information to Elasticsearch in order to index 100 documents in one shot. As I mentioned, if you have any error, we throw an exception. For instance, if you try to get a document that does not exist, you will have back a missing 404 exception. How you can manage this? You manage using try catch as usual. So for instance, here we are we want to read a document with an unknown ID that does not exist. We perform the get. Under the try catch, we can get the missing 404 exception, and we will manage in this case printing the message document not found if the document does not exist with the specific message from the Elasticsearch client. Okay, I just give you some flavor how to use the client, how to index to bulk some document. Let's focus now on search. That is, of course, most interesting feature of Elasticsearch. So basically, we offer all the possible query and parameter exposed by the REST API. So using the Elasticsearch-php client, you can perform all the REST API with all the parameters that you can perform on Elasticsearch. For instance, you want to perform a simple query. So you want to match a query of a field that is named test field, and we are looking for ABC term inside this document. So this is a simple match. As you can see in the body, we have query match. So very straightforward. And we have the search endpoints. So we pass the parameter. The search will map into the search API. That is one of the biggest, as you can imagine, API with a lot of parameter, a lot of possibility in Elasticsearch, and we will have back the results. So in the results, you will have this associative array with the first hits fields and another hits. So hits will contain basically the results of the search. So if you want to introspect the results, you have just to iterate into this its element. That's it. Another interesting feature of the client is because the majority of example in the documentation of Elasticsearch, or even on Google, if you Google, you find some example that someone is using Elasticsearch to perform, complicated or complex, query, and you have the JSON basically. You can say, look, I don't want to translate the JSON into associative array and put in $params. I would just reuse the same JSON that I have. You can do this. You can specify actually in the body of the $params directly the JSON. In this case, I put in the $JSON variable, JSON document, that is the query, the same query that I showed earlier. You can just specify as a JSON, as a string, and pass it to the body. This will work as expected. So the result will be the same of the previous slide. So again, this can be interesting, this be convenient if you have already some JSON that you copy and paste from the documentation of Elasticsearch, or you have another project written in other languages. If you have this common JSON, you can actually reuse it if you want. One interesting feature of Elasticsearch is scrolling, because of course, if you are using Elasticsearch, I'm assuming that you are indexing a lot of documents, a lot of data. And of course, the results will be, I don't know, 10,000 results, 1,000 results, and so on. So you cannot expect to have a JSON of 10,000 results. So Elasticsearch is performing pagination, that is called scrolling. So basically, you can paginate over the results from Elasticsearch, and this function is called scrolling. Maximum right now is 10,000 hits. That's, anyway, it's a lot of information. Generally, if you're scrolling, this is more efficient than regular search because it does not need to maintain an expensive priority queue for ordering the documents. So if you are using the pagination, you will get even better performance for the search. And it works using a point-in-time snapshot. So basically, each time you perform a request of scrolling, Elasticsearch will will freeze the response using a snapshot. Snapshot is like to freeze, the results of in this case of a search. Why we need to freeze this? Because otherwise, if we perform, I don't know, 10 pagination, you can expect to have different results in the pagination. Because if you are inserting a lot of documents, for instance, if you are, I don't know, give you a practical example. Imagine that you are using Elasticsearch to store the log of an intensive application. So the log are written, every, 10 milliseconds. So a lot of write in Elasticsearch. And you want to search using this log. Of course, if you don't use this approach of snapshot, each time you paginate, you will get different results. So basically, the number of pages that you will get back can increase or decrease if you are deleting information. So in order to prevent this, misunderstanding, you can actually Elasticsearch perform a snapshot, but you have to pass this point in time. So it's like a flag, it's like an index, an ID that give you the possibility to say, look, I give you this point in time, so please give me the pagination of this point in time. So basically, if you want to perform a scrolling, you need to enable it when you create a search, and you have to pass this scroll ID, that is this point in time dimension. Just give you an example, so maybe it will be better to understand. So imagine that we want to perform a query. So we are interested in query all, we perform a match all. So basically, we are searching for all the documents inside, all the terms inside our documents. we have to specify the scroll here, that is the 30 seconds. So this is the time frame where the snapshot will be alive, basically. The size, so we are saying, okay, we are interested in having for each page 50 documents, the index to documents, and the query. In this case, again, it's a match all. So when we perform a search, we can basically do a loop, in this case using a while, where we are saying, okay, look, there are some information in results. So if it's set hits means that there are some results. And this count, so this basically array is greater than 0. Okay, while this is true, we can scroll on the pagination, and we can actually, as you can see, the first API is search. The other are just scroll, because we need to pass actually the scroll ID. So this is actually the results of the previous search. So the first time this is executed, dollar results is populated by this search. The second time inside the loop, the dollar results is populated by the scroll. So we are saying, look, we are looking for this scroll ID, and internally Elasticsearch can understand, okay, this is a scroll ID, so I can give you the information of this snapshot. So it's not performing against basically another search. So this is also why it's faster, I mentioned earlier. And you can also change the lifetime of this snapshot, that in this case is 30 seconds. So basically, using this approach and a while loop, you can actually paginate over the results in a very efficient way and get back all the information that you need. Okay, let's jump to another interesting feature of Elasticsearch, that is the fuzzy search. What means fuzzy? Fuzzy basically means that you want to search something, but even if you are misleaping some character, or you write something that is not exactly the same term into the document, you will want to have back the results. This is very familiar, even on popular engine like Google. When you write something and you misleap something, basically Google will say, did you mean this? Because it's able to understand that he was meaning the correct sentence. And how it is implemented actually. In Elasticsearch, we are using the Levenstein edit distance. So Levenstein is basically the name of this algorithm. That basically the edit distance is the number of one character changes needed to turn one term into another. Let's give you some example. Imagine that you have the box word and the fox. So imagine, I don't know, fox is inside the Elasticsearch document, and you write in the search box. You want to have also fox, because maybe you mislead B with F, and you change the B with F, so you want to have it also fox in the results. And this is not possible in, for instance, if you have a relational database where you have you are performing a select. It's not possible to have this, or at least not all the database support this this feature. Another example is when you remove a character. So you have black and lack. So you remove the B, and you will have the same edit distance. That is actually 1, because you're changing only one character. If you insert a character, so sick and sick, or you transpose, so you change the position of two adjacent characters, for instance, act and cat. These are all example or Levenstein edit distance 1 that are managed by Elasticsearch. So Elasticsearch is able to give you also this kind of results. Let's do an example how we can perform a fuzzy query in Elasticsearch. We have to specify inside the query parameter the fuzzy. And here we are just saying, okay, look, I want this on this field of my JSON structure, the value Harry. So we are looking for all Harry term inside our document. And we are just performing a normal search. So the fuzzy search, there is not a specific endpoint. It's inside the search endpoint. Okay, so imagine that inside Elasticsearch we have 3 documents, document 1, 2, and 3, and these are the document. So the first is the string, I will marry you because I love you. The second is I will lie with Harry, and the third one is I'm sorry for your loss. So if you are looking for Harry here, using a fuzzy approach, also Mary will be insert in the results. Of course, Harry is the same term, and in the third document there is no, it will not insert into the result because the distance of Harry from all the terms inside this document is greater than 1. In fact, if we are going to measure the Levenstein distance of Harry and Mary is 1, because just change the first character H to M, and we will have Harry. So 1 is insert into the results of Elasticsearch. 0 is insert because it's the same exact term. In the last example, doc3, Harry, the shorter the nearest word is sorry, actually, in this document, and sorry, the Levenstein distance from Harry is 2, but 2 is greater than 1, so it's not insert by default in Elasticsearch. Why we choose to have only 0 and 1, so Levenstein less than 2? Because if you put more 2, 3, and so on, you will get a lot of results that are not so convenient to have to manage in your application. Basically, you will have a lot of bad results. So we suggest to stay with the 0 and 1 basically. Another nice feature of Elasticsearch is aggregation. Of course, you have a lot of data, a lot of document you want to aggregate with some criteria. So aggregation basically is useful if you want to summarize your data as metrics, statistics, or other analytics. For instance, you want to answer to question like, what's the average load time for my website? Who are my most valuable customer based on transaction volume? So imagine you have an e-commerce application. What would be considered a large file on my network? How many products are in each product category? This is another example of aggregation. So just to give you an example, how we can perform aggregation, we are always using the search. So as I mentioned, search is a quite huge endpoint that contains a lot of different possibility, a lot of different parameters. One of this is ags that stay for aggregations. So basically here we are saying, okay, look, we want to ag using this my ag name, aggregation name. So we are creating this aggregation name, and we are aggregating all the terms that are, all the fields that are stock. So imagine that you have a document like the stock options. You perform, you insert into Elasticsearch all the stock options with all the prices for, I don't know, 2 months. And you want to aggregate for one stock option. Of course, the stocks has a fixed name, so you want to aggregate all the information, extracting only the stocks that you want. So basically, you will have a very long associative array, and actually the aggregation is inside the its aggregation and buckets. So this is the results that you are interested. So it's not its, but it's in this case it's under aggregation, and you will have buckets. So these are the results of your aggregation. Another cool feature is highlighting of Elasticsearch. This is quite popular, especially on website where you perform a search, a web search, and you want to highlight all the document that contains the term that you wrote. For instance, you have a kind of search here, a form where you specify the miles, and the Elasticsearch will perform the results, and for each line we'll highlight here with a CSS, so with a specific HTML tag, the term that you wrote, so you can see where the term was in the document. How we can perform this? basically we need to perform again a search, but we need to specify that we want to highlight. So basically, as you can see, the first part of the body is almost the same that we had previously with the query match. So we are just matching the name that is a specific field in the document with AAL, for instance. And we need to add the highlight parameters here, where we specify, look, I want to highlight which field, the name. And here, this is the example that I mentioned earlier, when you have an empty JSON body. So here we need to have an empty object. So I just created a new standard class. And you will have you need to perform the search, and the results, actually, this is interesting. You can actually loop inside the hits. That is the usual way to collect the results from Elasticsearch. And you can print the highlight name, and you will get something like this, where basically all the highlight terms that are results from Elasticsearch are added using this EM tag, HTML tag. So you can just basically perform, I don't know, a CSS. You can just specify the color of the CSS of this EM tag, and this will highlight, the results. So very, very simple. This is quite, again, popular and powerful if you are building a website, you want to perform a search using Elasticsearch. A very new feature that we introduced in Elasticsearch 7.12 was the schema on read. This is very interesting. So basically, imagine that you have a document with a specific structure, and you want to create a field when you perform a search query that performs a script. So you want to perform a script inside a query. So when you read information, not when you are indexing or updating any information, you want to perform some operation when you read information. So basically, imagine that you want to adapt or changing a log format in the example that I showed earlier, or fix an index mapping. You can do when you are reading the information. You don't have to change the structure, the data inside your document. Or imagine that you are collecting information, but you don't have intimate knowledge of the data. So you can use runtime fields and define your schema without impacting others. So basically, you can test, experiment with the data just to understand how the results will be without changing the results itself in the search. So very, very interesting. Give you an idea. Imagine that we have the stock option database in Elasticsearch. So the example that I mentioned earlier. So basically the stock option, the value, and typically you have high and low value in 1 day of transaction. And we want to create another field in the response that is the average of the high and the low stock option. So the average is not present into the database. It's not a field in Elasticsearch. We want to create on the fly when we query the database. So what we have to do is to use a specific script language that is painless. This is the name, painless. If you're interested, you can check it out on the documentation of Elasticsearch. And as you can see here, we are creating a script inside the runtime mapping. So we are creating a runtime mapping, a runtime field. This is the name of the field that we are going to create, average. This is the type of the information is the double because it's average. So it's a floating point. And in the source of the script, you have the script itself. In this case, it's very simple. It's the sum of the two elements that are stored into Elasticsearch, and you can get it using doc.i.value, doc.low.value. So basically, I and low are the name of the field inside the Elasticsearch document. You just perform the average. So basically, you sum it and divide by 2. And that's it. And you emit. Emit means give me the results, print the results. And the name that we are going to create is average. Again, this is created only on the query result. It's not created inside the Elasticsearch database. So nothing written inside the Elasticsearch database. Is just a new field that come out in the results. So very, very interesting. I encourage you to have a look at this schema on it, because there are very, very nice application out there. Okay, you can perform actually all the endpoints that I mentioned using an asynchronous approach. We call it future or async mode, and basically you can send all the HTTP in parallel. So you can perform, no blocking application using Elasticsearch-php. And this, of course, can be a very nice boost in terms of performance. As we know, PHP is single thread. Basically, the majority of the logic of the engine of PHP is single thread. However, we have some workaround to perform, parallel operation, or at least not blocking operation. One of these is using the libcurl. That is, the curl is the client that is used internally by Elasticsearch PHP, and libcurl offer a multi-interface feature, so the ability to execute multiple HTTP calls in parallel, basically. How we can leverage this feature? Very simple. In the $params, we need to specify client future lazy. So this couple of information, and this actually, when you perform a get in this case, so we are calling the endpoints get, the next execution here will not block. So basically, the get function here will not block the execution. So the execution will continue. When you introspect the results, so when you go to read actually the $future, so in this case the next row, this will force the future to be resolved. Of course, because here we are saying, look, I want to know the value of the underscore source field of $future. Remember, $future is always an associative array. In this case, if you specify future lazy, internally is not an associative array, is an object. But when you access it as an array, it will be blocked. So it will be wait that the results needs to be sent from Elasticsearch. So if you don't read the $future here, the script will continue execution. So this is no blocking mechanism. And actually, this is interesting, because if you leverage this feature, you can do, for instance, you can get 1,000 documents in parallel without blocking. So imagine that you have this scenario. You need to read a lot of documents from Elasticsearch. You can leverage this feature of futures and storing all the futures in an array. As you can see here, this is just a for loop with 1,000 cycle, and for each of this we are just getting, so we're just reading the document in Elasticsearch, and we are storing it in an associative array. Unless we are not reading the $futures array, this will be performed in parallel. So the throughput of this script will be much faster using the future lazy. When you read it, specific document, you can force the resolution using the wait function. So wait function is basically a way to force the resolution of a specific HTTP call. If you are interested, you can have in the documentation there are more, example and more in-depth explanation. Okay, let's finish my presentation with talking about the future. So what we are going to do for the next major release of Elasticsearch-php, that will be version 8. So the goal is to have a completely new client, a brand new client with Elasticsearch request and response types. So basically, what we are doing is to collect all the possible response from Elasticsearch and creating the specific type, the specific classes, in order to have a typed client for Elasticsearch in PHP. So no more associative array. This is very cool because basically you can leverage auto-completion. So you will not need to read documentation to understand where the results are. Everything is fluent. Of course, we will going to use PHP 8 because we want to leverage the new feature of PHP 8. There are a lot, very interesting. Just I mentioned here in the slide just a few. For instance, named arguments, so the possibility to specify the function, the parameter using the name of the parameter with changing the order of the parameter. So this is very, very interesting. The union type, because we need union for having request and response type, the constructor property promotion, etc. That means that the new version of PHP Elasticsearch PHP will work only on version 8, at least the new client. We are going to support also the old one, so the actual one, so using the normal approach of the associative array, even for 8. So you don't have to, you can upgrade your application using these two different approach. So again, we will have the support for the old associative array, and the new one we're using basically a new project, a brand new project. We also going to support PSR standard, in specific PSR 3 for login, 7 for HTTP messages, 17 for HTTP factories, and 18 for HTTP client. So internally, basically all the HTTP message will be PSR 7. So everything will be more, standard. Also the possibility to inject, if you want to use your, favorite HTTP client. I don't know, the Symfony client, for instance, you can just specify that you want to use it, and internally the PHP client will use this to perform all the HTTP request and response. And of course, we will continue to support asynchronous HTTP call. If you are interested in look how the new client will look like, I suggest to have a look at this project, Elastic Transport PHP. That will be the core, that actually is the core of the new client in PHP for Elastic products. Okay, I finished. Thank you very much for your attention. If you need more information, you can check it out, the Elasticsearch PHP documentation and the Elasticsearch GitHub repository. Thank you.